The keys are posted on my website. You got a new quiz that's due Monday. If you can't be here, please be sure to fax or scan and email it in by Monday, and that will be fine with me. Okay, so today we are finishing up chapter 10. We're going to do some examples in 10.4. And then we're on to chapter 11. So chapter 11, 3 sections there, and then we have the stuff on ANOVA. So in the ebook, you'll see that I just changed it last night so that you go down through the chapters and you'll see, because you go chapter 12, blah, 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 and then you see where it says ANOVA. So I turned that chapter name into where it says ANOVA. And then you click there, and then I wrote a little subscript there. Click here, and then click on C.4 in the next menu. And that's how you access the ANOVA information. So it was a little buried, because it comes on the CD with the book. So if you have a physical book, you're not going to have it in your book, because it's on the supplemental CD. Okay, anyone have questions today? Questions on past stuff? So be aware and be remembering that if you're on any wait lists, or if you haven't paid your fees, okay, you might be getting emails regarding that. So make sure that you are aware of what's going on with your Napa College, what do I want to say, your Napa College information for next semester. Okay, so we went over 10.4 last time, which is testing a hypothesis about a proportion. And I was just getting ready to do some example problems there. Does anyone have questions before we launch into that? Yeah? Y'all good? Everybody good? Speak now or forever hold your peace. Just kidding. So, a lot of things stay the same in 10.4. We are testing hypotheses involving one population parameter. Okay? I tried to make the corrections on the quiz very clear. So if you have questions about your answers and why I deducted points, if I did, be sure that you understand, okay, what those corrections would be. Again, the key is on my website. And otherwise, you're absolutely welcome to talk to me about that, and I highly recommend it, actually. Okay, this is problem number 13. It's on page 499. So we've got page 499. And it's a hypothesis test of one proportion. It says, in December of 2001, 38% of adults with children under the age of 18 reported that their family ate dinner together 7 nights a week. Okay, that's in 2001. So there's your set proportion that has been established. Okay, everybody cool with that? Okay. And note, there's nothing about mean. It's a percentage. Okay, you with me? It's a percentage. In a recent poll, 403 of 1122 adults with children under the age of 18 reported that their family ate dinner together 7 nights a week. Okay, so we have how many people surveyed? 1122. And how many of them reported that their family eats dinner together? Okay, so that's your X successes in N trials. You with me?
Yes.
That's your P hat. So notice when you are identifying, is this about means? Is this about proportions? Because it's going to be one or the other, not both. Right? Yeah. One or the other. Notice that you don't see anything about mean, you don't see anything about average, you don't see anything about standard deviation, okay, those words. You get percentage, okay, the percentage that is established, and you've got successes in N trials. You with me? Okay? Okay, good. Has the proportion, keyword, of families with children under the age of 18 who eat dinner together 7 nights a week decreased? Okay, keyword, okay? Use the 0.05 significance level. All right, let's do it. So what's our established proportion? 38%. We can't do math with a percent, right? So you got to switch that to a decimal.
0.38.
Yeah, good. So you got 0.38. And note, use the correct notation. We're talking proportions now, not means. All right? You with me? And the alternative is, okay, same parameter, same number. What's the symbol?
Decrease.
Decrease. So
Less
than. Good. Okay. And that's what kind of test? Left tail. It's a left-tailed test. Okay. So what's our other information? So we've got an X, we've got an N, and we've got a significance level. So what is our number of successes?
403.
403. How many trials?
1122.
1122. Excellent. Alpha?
105.
5%. Good, good. Okay, so you guys, not every test is a two-tailed test, right? So I saw some of that in the quizzes, which I graded just like a split second before I came running over here. So be sure that, remember that your type of test is determined by the symbol in the alternative hypothesis, okay? So in this case, we're specifically looking for, and remember that the distribution of p hat is normal, okay? So our established p is 38%. Okay, so, and remember, that is the mean of the p-hat distribution. That is the mean of the p-hat distribution. Okay? So, we want to know how far away our p-hat is from the established mean in terms of standard deviations. Okay, what is that p-hat approximately? 403 divided by 1122, what do we get?
359.
0.359? Thank you, Paul, 0.359. Okay. Actually, we're looking for whether or not the percentage decreased. Note that this percentage is a little bit smaller, but we're looking for a significant change, right?
Yeah.
Come on in, Keith. Mandy, what do you got?
How did you get the X? How did you get the X?
The X is the number of successes. So the question is, how do we get the X? It's the number of successes in our N trials. So 403 of the 1122 reported that their family ate dinner together 7 nights a week. It comes from a binomial. It's like how many successes in those N trials. So out of our 1122 people or families surveyed, 403 of them answered that their family eats dinner together 7 nights a week. You guys with?
Mm-hmm.
Does that make sense? Yep, everybody okay? All right, good. Okay, so now we are interested in how far away our sample statistic sits from our established parameter in terms of standard deviations. Overall here, we're talking about the distribution of p hat, okay, because it's our estimator for the population proportion. We know that p hat is normally distributed under certain conditions, and of course those conditions in this case have to be met because otherwise we'd be lost, right? The mean of the p hat distribution is p. The standard deviation of the p hat distribution, and I'm going to go over here for that. So the standard deviation of the p hat distribution is square root of p times 1 minus p divided by n, which in this case is going to be the 0.38 times 1 minus 0.38 divided by 1122 and square root. But we are going to use our calculator. Okay? I don't particularly think that this is a good use of time to simplify that thing. What would be 1 minus 0.38? What's this part? Well, that'd be 0.62, is that right? So this part here is 0.62. So you go 0.38 times 0.62 divided by 1122, and then take the square root of the answer to get an estimate. Okay, so our graph, according to our 5%, okay, left-tailed test, right? So that 5% significance level goes into the left tail. The critical value corresponding to 5% is what?
Minus 1.96.
1.96? Good.
I don't know.
And-
Just guessing.
No, I think it's 6.5.
Is it 1.96?
1.645.
1.645 with 5% in the tail? Okay. So, and then we'll assign a negative to it because it's on that side of the distribution. Okay, so we've got negative 1.645. And remember, that's a z-score. This is the distribution of p hat. Our critical value is in terms of z. Okay? So now we'll see where our test statistic sits in relationship to the
P hat.
the established p. Okay. Okay. So we've got our test statistic is going to be p hat minus p divided by this thing. So this is a z-score because it deals with proportions. Proportions are always z-scores. Same thing with that critical value. Okay, you never have to worry about z versus t with proportions. It's always z. And just like if you're zing an x bar, right? It's x bar minus mu divided by the standard deviation of x bar. So it's the sample value minus the population mean divided by the standard deviation. Okay, same thing. So our p hat is about 0.359 minus our established p. And did we ever get a decimal approximation for this critter?
0.014.
0.014? Can anybody agree or
Yes.
0.014? Whoops.
Are we ever going to ask in this class how they got the population mean of 38%? Because they just give it to you in the problem. Because how do you go about getting a population mean?
That was the previously established fact. So it probably came from a point estimate
Oh, of something
from
else.
2001.
Yeah,
Yeah.
that's what I'm guessing.
Yeah.
Okay,
Yeah.
all right.
Well, that's part of it, right? Is that we don't have these population values,
Right,
and
so
that's why that's what we're estimating.
they did what we're doing now in 2001.
You got it.
And before that, someone.
Right.
So when the population was small, you were able to get a population mean. No?
Right. Well, if the population is a manageable size, yeah, you can get a population value. Otherwise, you're
And now
estimating.
it's 6 billion, right?
Something like that.
Yeah.
Yeah. So now you go, well, how likely is it that we are going to know, the proportion of all households in the United States that eat dinner together 7 nights a week? It ain't going to happen, and therefore we estimate.
All right.
Yeah, you got it. So, what do we have?
Negative 1.4.
Negative 1 point.
I used the whole decimal. It's like negative 1.44 is what I got.
Negative 1.44. You used all the decimal places here, Ben?
No, for the p hat.
P hat? Okay, it's probably more accurate then.
Negative 1.5.
Sorry?
Negative 1.5.
Negative 1.5? Negative 1.5? Okay, let's use negative 1.5. Negative 1.50?
No.
Two decimal places.
Oh, got it.
Negative 1 point. It's a z-score, right? 2 decimal places is good.